Hello everyone, today we'll be solving the CPT June 2018 question paper. We'll be solving questions which came from the quantitative section of the paper. Today we'll be solving question number 54 and question number 55. So these are the two questions that we'll be solving today. So let's start off with question number 54. So in question number 54 it has been said that if A is the set of elements x, where x is equal to 3 to the power n minus twice n minus 1, where n belongs to the set of natural numbers, and if b is the set of elements x, where x is equal to 4 into n minus 1, where n belongs to the set of natural numbers, then option A is a subset of b, option B is a subset of A, option C, A is equal to B, and option D, none of this. So these are the four options that we have been given. So what we'll be trying to do over here is that we'll try to build the sets A and B. So to build the sets A and B, first let us take the values of n. Let n be equal to, we can take, since it is natural number, 1, 2, 3, 4, and this will go on. So these are the various values of n. And then we'll have corresponding values in the set A, and we'll also have corresponding values in the set B. So now if we put n equal to 1 in set A, so this will be 3 to the power 1. So we'll have 3 to the power 1 will be 3 minus 2 minus 1. So we'll have set A, we have the element 0. And similarly, if we put n equal to 1 in set B, then we have 4 into 0, that will be also 0. Now if we put n equal to 2 in set A, so this will be 9 minus 4 minus 1. So 9 minus 5 will be 4. So we have 4 over here. And if we put 2 in set B, n equal to 2 in set B, then 4 into 2 minus 1, that will be 4 into 1, and that will be equal to 4 again. Now we'll put n equal to 3. So n equal to 3 in set A will be giving us 3 cube will be 27 minus 6 minus 1. So we'll have 27 minus 7, so that will be 20 over here. And then we have, if you put n equal to 3 in set B, then we have 4 into 3 minus 1, that is 4 into 2, that will be 8. And then now we'll put n equal to 4 over in set A. So we have 3 to the power 4, that will be 81 minus 8 minus 1. So 81 minus 9, that will be 72. And then we have, if we put n equal to 4 in set B, then we have 4 into 4 minus 1, that will be 4 into 3, and we have 12, and this value goes on. So therefore now we can write that the set A will seem somewhat like this: 0, 4, 20, 72, and so on. And the set B will look somewhat like 0, 4, 8, 12, and so on. So as you can see over here in set B, these are all multiples of 4. And in the set A also we have values which are multiples of 4. But as you can see, the values which are in set A are already, all the values which are in set A are available in set B, but the values which are in set B, suppose for example 8 and 12, these are not available in set A. So we can therefore say that the set A is a subset of the set B, and that gives us that option A is the correct option. So option A over here is the correct option. So this is how we solve question number 54. Now we'll move forward to the next question, which is question number 55. In question number 55, we need to find out the range of the function x to the power 6 upon x to the power 12 plus 1. The options given are close interval 0 to infinity, option B close interval 0 to 1 by 2, option C minus infinity. Right, there has been a mistake in this range, in this interpretation, but nevertheless let's move on to the next option, close interval 0 to 1 by 2. So these are the options that we have been given. So now we have been given that the function f of x is equal to x to the power 6 upon x to the power 12 plus 1. So what we'll try to do over here is that we'll try to bring this x to the power, we'll divide both the numerator and the denominator by x to the power 6. So we'll finally land with 1 upon x to the power 6 plus 1 by x to the power 6. So this will be the final structure. Now, using the relationship of AM is greater than equal to GM, we'll see that if we take x to the power 6 and 1 by x to the power 6, so if these two numbers are considered and we need to find out, we apply the AM-GM relationship over here, then we'll see that x to the power 6 plus 1 by x to the power 6 upon 2 will be greater than equal to root over x to the power 6 into 1 by x to the power 6. So this will give us x to the power 6 plus 1 by x to the power 6 by 2 will be greater than equal to 1, which will ultimately give us that x to the power 6 plus 1 by x to the power 6 is greater than equal to 2. So this is the value. So that implies that if we reverse it, then this will give us 1 by x to the power 6 plus 1 by x to the power 6 is less than equal to 1 by 2. So that implies that f of x is always less than equal to 1 by 2. And also we can see that this value x to the power 6 upon x to the power 12 plus 1, this value f of x is always greater than equal to 0. Okay, always positive. Not always positive, but we can say it's greater than equal to 0. So that implies the range therefore will be, we have, if we take this as equation 1 and take this as equation 2, then 1 and 2 implies that 0 is less than equal to f of x and this is less than equal to 1 by 2, and therefore the range is equal to the set close interval 0 to 1 by 2, which is the option we can take as you can see B and D are the same options, but we will go over option B. So option B over here is the correct option. So today we have solved question number 54 and 55. We'll be solving the next questions in the subsequent videos. Till then, keep watching Software Class videos for more solutions and content. Thank you very much.